All right, so let's take a quick look at the 5.5 homework, rectilinear motion, motion in a single plane. Again, key ideas coming out of this section is that we've got our position function, its derivative is velocity, so our velocity function. The second derivative of position is the first derivative of velocity, and that is our acceleration function. All right, so in 1A, and I think for 2 as well, it asks when is the particle stopped? Well, if the particle is stopped, I want the velocity to equal 0. If I want velocity, I'm taking the derivative of position. So I use my power rule, derivative of 2t cubed, derivative of negative 21t squared, derivative of 60t, and then of course the derivative of 4 is 0. I set my values equal to 0. I factor out a 6 to make the factoring easier, and I end up with t equals 5 and t equals 2. So I know the particle has stopped at t equals 5 and t equals 2. Problem didn't really ask us to do this, but at this point I could even make a sign pattern of velocity, and that would tell me when my particle is moving to the right is when my velocity is positive, when my particle is moving to the left is when my velocity is negative, and then I'd be able to say that I change directions at 2 and 5 because the signs change as I cross 2 and 5. Kind of things that we want to keep in mind, especially looking ahead to our Chapter 5 test. Part B wants to know what direction we're moving when when t equals 3. Well, from my sign pattern, I would already know that we should be moving left, or since they've given me a specific value, I can substitute that value into my velocity function. The fact that I got negative 12, the most important part is the negative value, and now I know since velocity is negative, I am moving left. Part C wants to know where the particle is located, and since they use the phrase where is it, we have to actually write out a little sentence or a little expression as our final answer. But again, if I want position, I substitute into my position function. I get 49, so I know that I am 49 units to the right of the origin. And yes, when it asks you where is the location or what is the position, we do have to actually write out that little phrase. Part D wants to know what acceleration is when t is 3. So whether you call it the second derivative of position, the first derivative of velocity, or just acceleration, basically I'm taking the derivative of the derivative, that gets me 12t minus 42. I substitute in, and I get acceleration as negative 6. Now, like we would have discussed in class, just because we get a negative acceleration does not guarantee that we are slowing down. It does not guarantee we are slowing down. In fact, since v of 3 was negative 12, and acceleration and velocity have the same sign, we would be speeding up. Again, negative acceleration does not necessarily imply you are slowing down. It's all about the sign of velocity and the sign of acceleration. 2 wants us to go through those same pieces. So if I want to know when I'm stopped, I want my velocity to equal 0. So I take my derivative of t cubed, my derivative of negative 6t squared, my derivative of 12t. To make my life easier, I was able to factor out the 3. And that leaves me with a perfect square t minus 2. So I know that I am stopped when t equals 2. If I were to make a sign pattern of this function, the only value on it would be the 2, and it would be positive and positive, which tells me that my function moves to the right, my particle moves to the right and continues to moving to the right. We may stop when t equals 2, but we do not change direction. All right, it asks what velocity is when t equals 3, so I sub 3 into my velocity function, and I get 3, so I know my velocity is 3. I would have already known that I was going to get a positive answer pattern, and so I can say the particle is moving to the right because velocity is positive. It wants to know position in part C, so I substitute 3 into my position function, and again I've got to write out this little phrase that expresses I am to the right of the origin because I got a positive answer. How far to the right? 14 units to the right of the origin. And then it wants to know acceleration, so I substitute 3 into my acceleration function, the second derivative of position or the derivative of velocity, depending on how you want to describe it, and I get 6. Now again, getting 6 does not guarantee that I am actually speeding up. What guarantees that I'm speeding up is that velocity when t equals 3 was 3, acceleration when t equals 3 was 6. Since these are both positive, that tells me I'm speeding up. All right. So number 8 wants to know x of t when velocity is 0. Well, if I want velocity, I take the derivative of my position function, so derivative of t cubed, derivative of negative 6t, derivative of negative 63t, and then of course the derivative of 4 is 0. Like we saw in those last couple, I can factor out a value to begin with, makes my factoring a little bit easier. Now, one of the things that we have to get used to is nowhere in the problem does it tell us time is greater than 0. And we would have discussed in class the idea that there is such a thing as negative time once you put things into context. So I'm not going to ignore this answer of negative 3. I'm going to substitute it in along with my positive 7 to find that I'm negative 388 units. So I've got 388 units to the left of the origin when t equals 7 and 112 units to the right of the origin when t equals negative 3. 10 wants to know position and velocity when acceleration is 0. So I find my first derivative, I find my second derivative, I set the acceleration function equal to 0 and solve, getting 3.5. So I substitute 3.5 into velocity and into acceleration. So I know that I am 42.5 units to the right of the origin, traveling to the left because velocity was negative. And since we've solved when acceleration was 0, I'm moving at a constant velocity. I'm not speeding up and I'm not slowing down. I'm traveling at this constant speed of 13.5, moving to the left. Multiple choice 2, you're going to need a calculator for this one. So I found my velocity function. I set it equal to 0, but I had to use my calculator to graph rows. Once I had those zeros, I was able to make my sign pattern between negative 3 and 3, since it tells us we're limiting the time to negative 3 to 3. And what I'm looking for is as I cross one of my zeros, does the sign on my sign pattern change? At negative 2.263 it does, so that means I've got a change in direction. When I cross my next zero, I get another change in sign, which tells me I'm changing direction, so this particle changes direction twice. Multiple choice 3 wants to know, I think when the particle is stopped, it's not worried about changing direction. So I take my derivative. If I'm stopped, velocity is 0, and I end up with t equals 3, choice 3. All right, this is going to lead us into what we look at in 5.6, where we compare parametric equations, which is basically 2 equations to describe total movement. Hope this helped. If not, feel free to ask questions in class.